Hi everyone, welcome. One exercise, 4 questions, all the topics. Let's go for under 15 minutes. Okay, before we start, I remember the first time, when I watched the first episode of Breaking Bad, and Mr. White said, chemistry is the study of change. And that's a great definition for chemistry. And it relates to enthalpy, which is our topic. Before I define enthalpy, we need to agree with the fact that for our purposes, all systems will be under constant pressure, no matter what, okay? For us, a system is always under constant pressure. When you go to college, that might be different, but for now, systems are under constant pressure. So enthalpy is the heat content of a system under constant pressure. But we want to know the change. Now, the enthalpy change is the heat lost or gained by a system under constant pressure. Because of that definition, we can say heat is equal to change in enthalpy. So Q equals delta H. Don't forget, that's very important. Q, heat, equals delta H, enthalpy change. Okay, now let's go for the exercise. Okay, let's read it. It says, using a coffee cup calorimeter, a gold sample with a mass of 60 grams is placed inside a cup which is filled with 40 grams of water. A. Calculate the energy gained by the water. B. Calculate the energy lost by the gold sample. C. Calculate the final temperature of the gold sample. And D. Calculate the enthalpy change of the system. 4 questions, but don't worry. Okay, step by step. Question number 1. Calculate the energy gained by the water. So the question itself is suggesting we're going to work with water. And we need to find the given which relates to water. Okay? So let's write the given. Now we have 60 grams, but this is the mass of gold. So for now, we're going to ignore it. And then we have 40 grams of water. So that is the mass of water. So 40 grams. And that's all we have as far as the text. But the image has more information. On the left side, we have the setup. The setup is the starting point of the experiment. And we have 40 grams as the mass of water and 20 grams as the starting temperature for the experiment. So that is the initial temperature for water. So Ti is equal to 20 degrees Celsius. And then notice we have this thermometer which is in contact with the water, and it reads 25.80. That is the final temperature because it recorded the temperature when the experiment was completed. So final temperature 25.8 degrees Celsius. Also, we have the specific heat of water. It's very small, but you can see it. Capital C is equal to 4.18 joules per gram times degrees Celsius. And we want heat gained or energy gained. Remember, they're the same. So Q is equal to question mark. And the step which I suggest you always do first is find delta T, change in temperature, which is temperature final minus temperature initial. We have both of them, so final is 25.8 degrees Celsius minus 20 degrees Celsius. Delta T is 5.80 degrees Celsius. I added the 0 just for significant digits, okay? but it's 5.8. Now, I could use the equation. I would prefer to use the equation and then do algebra, but because of the time, I'm just going to use the triangle. I want to find Q, so I cover up Q with my hand. It has a glove because we're compliant during this pandemic. So we write the equation. Now we have nothing on top because it's covered by the glove, and we have MC delta T next to each other. That means they're going to be multiplied. Okay, so Q or heat is equal. Okay, let me move that a little bit so it separates. So Q is equal to mass times specific heat times delta T. Q equals MCAT, that's the way I say it, but it says heat is equal to the mass times specific heat times change in temperature. Then we can just substitute. So Q is equal to 40 grams, which is the mass of the water. I'm not going to write the 0.0 just for the sake of space. And then C, which is 4.18 joules per gram times degrees Celsius times change in temperature, which is 5.8 degrees Celsius, close parentheses. And all we do is multiply all of that. So let's do it. 40 times, okay, got stuck, so let's redo that. There you go, 40 times 4.18 times 5.8. Press enter. 969.76. 3 significant digits, so we're going to round this to 970. Okay. We're going to write it over here. Heat gain is 970 joules. How do I know if I should write it as a positive or negative number? This is energy gained. So most of the time we have energy gain that is going to be a positive number. Okay. Plus, I should mention the system is the gold because we're going to see what happens with the gold, okay? And the surroundings are the water. Or is the water, okay? So energy gained by the surroundings would be a positive number, which is 970. Next, question B. Calculate the energy lost by the gold sample. This one's very simple. As per conservation of energy, heat loss should be equal to heat gained. If the surrounding gained 970 joules, the system, which is the gold, should have lost 970 joules. And the way you write it is with the negative number. So heat lost 970 joules. Very simple. Next, I think this is the more complicated one, but don't worry, I'm going to show you step by step. Calculate the final temperature of the gold sample. Now we're going to be focusing on gold. So gold sample, we have the mass. Start with the given as usual. Mass of gold is 60 grams. And that's all we have. We go again for the setup. 60 grams of mass. 152 starting temperature. So that is the initial temperature. 152 degrees Celsius. Then we have specific heat for gold. You can see it, 0.128. So capital C equals 0.128 joules per gram times degrees Celsius. And we have heat from a previous question, which is 970 joules. negative or minus 970. This is important. You'll see why. The negative sign. Negative 970 joules. Then we do that J. There you go. And we want temperature final. Now we don't have an equation for temperature final, as it were, but we can use the triangle. So let's cover up delta T because it deals with temperature. And it reads Q on top, MC on the bottom. That means Q will be divided by the multiplication of M times C. Change in temperature is equal to heat divided by the product of mass times specific heat. So let's write it down. Delta T is equal to Q divided by M times C. Now we can substitute. Delta T is equal to the heat, which is negative 970 joules, divided by parentheses the mass. Again, for space, I'm not going to write the 0.0 times specific heat, 0.128 joules per gram times degrees Celsius. Let's do that operation. So parentheses, we're going to add a negative 970. Got stuck. Let's give it a moment. There you go. Divided by 60 times 0.128. Close parentheses. Press enter and we have negative 126.3. Negative 126.3. We have three significant digits, so I'm just going to say negative 126. But you can do either one, okay? You know what? No, let's just 126.3. You'll see why. So we have delta T is equal to negative 126.3 degrees Celsius. So we have delta T and we have initial temperature. We know delta T is equal to final temperature minus initial temperature. So if we want the final temperature, we have to solve for TF. This is a subtraction sign, so the opposite would be addition or add it. If we add initial temperature on both sides, we're gonna have TF by itself. So plus Ti on this side plus Ti on this other side. These two cancel and our equation would look like this. Temperature final is equal to change in temperature plus initial temperature. Now if we substitute, it'll look like this. Temperature final is equal to change in temperature, which is negative 126.3 degrees Celsius plus initial temperature 152 degrees Celsius. Let's do the operation now. So parentheses negative 126.3 parentheses plus 152 25.7, and that is three significant digits, So 25.7 is equal to the final temperature. Oh, I forgot the units. My mistake. I almost lost a few points. There you go. Not that hard, let's be honest, okay? And that's the final temperature. Last question. Calculate the enthalpy change of the system. Now we need to know if this is an exothermic or endothermic. Remember, what's happening with the energy in the system? So the gold was hot, and then we placed it inside the water, and then it became cooler. If something gets cold or colder, if it decreases in temperature, it's releasing heat. So it's an exothermic, okay? Exothermic reaction. Now, I stated on the notes that for exothermic reactions, enthalpy change will be negative, okay, for exothermic. And then enthalpy change is Q for the gold, as you can see. Thus, we can write Q is equal to delta H, for our case, would be equal to negative 170 joules. Oh, let me redo that J. All we needed to know if it was exothermic, endothermic. And that's it, guys. That's it. Bye.